The billion-dollar question that has stumped astronomers is whether the cosmic narrative tosses an infinite curveball at our knowledge of the prehistoric Big Bang. Is the very building block of our cosmological chronology incorrect? Here's the catch: there's a 70% possibility that the star named Methuselah, which is alternately referred to as the Divine Drifter, may not be able to neatly fit into our current models. There's even a 13.66% chance its age challenges cosmic law as we know it, and a 15% probability that it's really younger than we think. Consider it rolling a six-sided die and wishing for a 6, it's numerically probable. Odds or no odds, one thing is certain. Methuselah's no ordinary old star. It's perhaps the oldest known. Scientists have given it an age tag that's surprisingly close, and that's where things get mind-bending. Rather than questioning how Methuselah can be billions of years older than its stellar counterparts, what if we turned the script on its head? What if the universe itself is older than we believe? Our knowledge of a 13.8 billion-year-old universe already stretches to infinity, like attempting to comprehend infinity. If you condense the entire cosmic timeline into 1 year, with the Big Bang on January 1st, Earth wouldn't show up until the very end of December 31st, and human civilization would take only the final 10 seconds. Scientists calculate the universe's age by looking at old starlight released a few 100 million years after the Big Bang. As the universe grows, that starlight gets stretched into longer wavelengths, a process known as redshift. On this basis, the researchers concurred to an age of 13.8 billion years. But wait, here's where things start to get wild. A theory coming out of the University of Ottawa suggests the universe could actually be 26.7 billion years old. Professor Rajendra Gupta resurrected a nearly century-old hypothesis from Swiss astronomer Fritz Zwicky. It posits that as photons travel across the universe, they lose energy, challenging what we've previously observed. Gupta proposes a hybrid model, combining this tired light idea with current expansion theories to explain redshift more comprehensively. The evolving coupling constants theory also has the concept of evolving coupling constants, which is physicist Paul Dirac's idea that the manner in which particles interact evolved over time. Revising our estimated age of the universe is no easy task. But it wouldn't be the first time. It was way back in the 1920s that Edwin Hubble estimated the universe at about 2 billion years old. Since then, cosmic mathematics have progressed a great deal, and this new vision may be a giant step forward in our knowledge. Nevertheless, whether this new vision becomes the new norm is still to be seen. Whatever the precise figures, what is certain is that the universe is a treasure house of ancient marvels. Beyond the Milky Way, there is a dazzling dance taking place between galaxies. Stars on the edges of our galaxy are moving less rapidly than stars in other galaxies. Why? One hypothesis is that our galaxy is in danger of running out of a ghostly, invisible substance called dark matter. Some 390 light-years from us, around 2.34 quadrillion miles, our nearest cosmic leads present us with just how enormous and alien the universe actually is. Humanity's quest for knowledge extends far longer than time itself, seeking to provide answers to some of humanity's oldest questions ever posed. The James Webb Space Telescope, with its mighty window into the past, recently caught sight of a structure older even than the creation of stars. This mystifying object is older than the universe itself, raising more questions than answers. How is it possible for something to be before everything else? Is cosmic history incomplete? As we track the James Webb Telescope on its journey, we're slowly peeling away the mysteries that go back as far as the birth of the universe. A tip-off is hidden in a star named HD 114283, which is close to the Libra constellation. About 10 billion years ago, our nascent Milky Way engulfed a dwarf galaxy where this old star once resided. But it isn't just the trip that captivates researchers, it's the star's sheer age. Called the Methuselah star, it was previously believed to be more than 16 billion years old, making it older than the universe itself. Its age, according to the latest estimates, is 14.46 billion years, plus or minus 0.8 billion. Even this new number is still older than the accepted age of the universe, leading scientists to wonder everything from the true age of the star to the equipment we use to measure time in space. It is extremely difficult to measure the age of stars. Stars such as our sun burn for billions of years, staying bright, large, and hot, and are hard to date. Scientists consider such as brightness, color, and particularly how quickly a star rotates, because stars wind down with time to estimate age. A second important technique is astroseismology, which examines a star's internal oscillations to infer age, similar to listening to seismic motion within Earth. With this method, scientists have aged the Sun at around 4.5 billion years. Methuselah's age was also estimated from its chemical makeup and location in the galaxy. Stars are divided according to how much bling, or heavy elements such as iron, they have. Our Sun, metal-rich, is a population 1 star. Methuselah, metal-poor, is probably a population 2 or even older. This gives rise to the population 3 stars, theoretical population 3 stars from the earliest times in the universe, which consisted nearly exclusively of hydrogen and helium. No such stars have been observed, but astronomers suspect that they were titanic, fleeting, and essential to the evolution of the cosmos. When they detonated as supernovae, they distributed the heavy elements throughout the universe. These formed population 2 stars, which went on to create population 1 stars such as our own Sun. But perhaps the most mysterious phenomenon in the universe is dark matter. This form of invisible stuff, which we can't see but can quantify by its effects on gravity, is believed to have a tremendous influence on the formation and behavior of galaxies. Information from the European Space Agency's Gaia satellite is now revolutionizing the way we perceive dark matter. Gaia has charted close to 2 billion stars, providing precise information on their motion. Strikingly, stars at the edges of the Milky Way galaxy are moving at slower speeds than predicted, indicating we may have overestimated dark matter. Certain scientists think perhaps we have been inept at our guesstimates. Determining the mass of a galaxy is very difficult, and perhaps our instrumentation should be fine-tuned. Still, a number of different research teams are drawing the same conclusion. The dark matter idea could be seriously out of date. If the new ideas bear out, then this has potential to revolutionize everything, rewriting our concept not only of our own galaxy but the whole cosmos. Back in the 1970s, astronomer Vera Rubin and her team first noticed something odd. Stars on the outer edges of galaxies were spinning at the same speed as those closer to the center, defying Newtonian expectations. This led to the initial proposal of dark matter's existence, which has shaped astronomy ever since. Even with all we've discovered, we're still like curious children staring into the vast unknown. Earth is a tiny island in an infinite ocean of stars, hurtling around the Sun in a galaxy filled with mysteries. Our quest for meaning and understanding fuels every scientific breakthrough. Even when the answers surprise us, our curiosity drives us deeper into the universe. Each discovery unveils a new thread in the intricate tapestry of cosmic knowledge, revealing the laws that govern existence. Today's science has revealed that galaxies are not alone. They are interrelated by a huge network of dark matter and gravity. This sets conventional thought on its head when it comes to galaxy formation and evolution. One of the most astounding findings is gravitational waves, disturbances in spacetime created by events such as crashing black holes. Discovered for the first time in 2015, gravitational waves provide an added tool for us to explore the universe. They enable scientists to see cosmic events that cannot be detected by conventional telescopes. In addition to this, astronomers are also venturing into the exploration of exoplanets, planets that revolve around stars outside our solar system. The discovery of potentially habitable exoplanets poses deep questions regarding life beyond our world. Using instruments such as transit photometry and radial velocity methods, astronomers are discovering a vast variety of planetary systems, many that defy our conception of how solar systems should appear. Some of these planets are in the Goldilocks zone, where conditions may be conducive to liquid water and, possibly, life. As we venture further into the universe, artificial intelligence is playing an increasingly vital role in interpreting the mountains of data collected. AI is able to locate patterns and spot new cosmic phenomena more quickly than has ever been possible.